Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about variable area elements change their area due to the movement between the primary element and the meter's body. Rotameters are variable area flow meters, in which a float changes its position within a tube proportional to the flow of the fluid. The float is in an equilibrium between its weight, the drag force of the fluid, and the force of the fluid thrust on the float. The flow depends on the specific weight of the liquid, its viscosity, and the values of the inner section of the tube since it changes according to the equilibrium point of the float. The equilibrium condition of the float, according to the forces acting on itself, is this, and solving the previous equations results in this. Being a diaphragm with a variable orifice, the rotameter will have a discharge coefficient that will encompass the uneven distribution of speeds, fluid flow contraction, pipe broadness, etc. For this, we add the term C to the previous expression. Then, the volumetric flow rate and the mass flow that pass through a rotameter are calculated with these formulas. This flow depends on the specific weight of the liquid and the inner section of the tube AW, since it changes according to the equilibrium point of the flow, which makes the choice of the size of a rotameter very laborious. Therefore, to simplify calculations, it is customary to refer the flow rates of liquid or steam and gas to their equivalents in water and air. These equations are used for this. Considering a 316 stainless steel density flow, for gases with temperature in Celsius and pressure in millimeters Hg, and neglecting Pg, it will be this way. And in the case of the vapor, being Vg the specific volume of the water vapor in service conditions and the flow being expressed in mass. The tubes used in rotameters can be made of glass and metal, and they are machined in such a way that interchangeability is ensured without the need of individual calibration. In the case of glass tubes, these can have internal ribs that guide the float or be smooth. Metal ones are always smooth conical and require an extension because they do not have direct reading. Both tubes have a taper that is expressed as the ratio between the internal diameter of the tube on the maximum scale and the diameter of the float's head. This ratio varies between 1.20 and 1.35. Now I will mention the four most used construction profiles. The spherical ones, which are used for low flow rates and where a lot of precision is not required. Used for medium and high flow rates with a medium influence of the fluid viscosity. Cylindrical, with projecting edge sloping face against flow, has less influence on viscosity and can compare to a nozzle for its flow characteristics. Cylindrical with protruding edges against the flow. They have the least influence of the viscosity of the fluid and their performance is compared to that of an orifice plate or nozzle. In this image, we can see the influence that the viscosity of the fluid has on the discharge coefficient of each one. The most widely used material in floats is 316 stainless steel. However, the materials indicated in these tables are also used, either for resistance to corrosion or for their ease of machining the upper edge. The scales of the rotameters are engraved on a brass or aluminum scale mounted along the length of the tube and located in coincidence with the zero line of the tube or directly on the glass tube. The scale can be graduated in percentage from 10 to 100% of the full scale, or in direct units of the flow depending on the service conditions. In the case of the percentage graduated scale, a multiplication factor is added to the readings to convert to units of volumetric or mass flow. Another way to set the scale is in millimeters, accompanying a flow reading calibration curve in millimeters to determine the flow rate of the fluid. The calibration curve is used in small capacity rotameters where the flow rate is not linear, within the range of 10 to 1 measuring range, which is the measuring range of the rotameters. And well, this will be all for today's video. Don't forget to give me a like and subscribe. I upload videos every Wednesday in Spanish and every Friday in English. Adiós! Don't worry. Don't worry. Don't worry.
Don't worry.
The scale can be graduated in percentage from 10 to 100%.